Factor completely. First, check for any greatest monomial factors, which there are none in this problem. Next, I'm looking at three terms. Well, I could use perfect square trinomials, except that this last number right here is not a perfect square. So I need to use my coefficient of 1 rule, which is the adds to multiplies rule. So, what two numbers are going to multiply to be 15, but add to be 8? Because those will be the numbers that go in the back of the parentheses here. And if I look at all my multiples of 15, there's really not that many. 3 and 5 come to mind. What goes in front? Well, I need somehow to get t plus 3 squared, so it must be t plus 3, t plus 3. I can clean this up a little bit. T plus 6, t plus 8. Factor completely. First look, I know that all these factors have something in common, and that is a z squared. So I'm going to factor that out first. Divided by z squared, whoops, divided by z squared, divided by z squared. So I'm left with z to the 4th minus 17z squared plus 16. What's left over in here is a trinomial. First one's a perfect square and the last one's a perfect square. But twice the product of those squares is not 17, so I know I'm going to need to use my coefficient of 1 rule, what adds to be and multiplies to be. So, the multiply is going to be 16, the adds to is going to be negative 17. So if I look at all my pairs of factors of 16, I see right here is the one that I want. So that means, coming down to here, I have my monomial factor in front. This will be factored to negative 1, negative 16. What goes in front here, though, is not just a plain old z. I need a z squared and a z squared in order to get my powers to be correct from up here. Now, take a look at what we have here. This is a dose rule, as is this one, difference of squares. So, the first one is going to be z, 1, 1, plus and minus. That's just this right here. This one, z, square root of 16 is 4, plus, minus. Whole shebang right there is its factored form. Factor. There is no greatest monomial factor between these three terms. So the next thing I'm going to check for is PST, perfect square trinomial. This is a perfect square, this is not a perfect square. So I need to then go to my coefficient as 1, factoring. Two numbers that multiply to be negative 18 and add to be negative 7. If I look at my factors of negative 18, 9, 3 and 6, the first one could be negative, or all the same factors with the second one being negative. I'm looking for this one right here, 2 and negative 9. So coming back to here, I know I'm going to have a plus 2 and a negative 9. But not just 2 and negative 9, I need to get an s to the 4th here. So I know both of these are going to have an s squared at the end. Let's clean that up a little bit. That was the marker, by the way. What goes in front? I need to get a t to the fourth. That means this must be a t squared, and this must be a t squared. Check my two factors to see if anything else is factorable. There are two terms here, but there's not a difference, so it's definitely not DOS. This one, though, is DOS. Difference of perfect squares. So I'm going to rewrite this factor, but this one gets the DOS rule. T minus 3s minus 3s. Factor. None of these have a factor in common, so there is no greatest monomial factor. Then I'm going to look for the perfect square trinomial rule. This is a perfect square, this is not. So now I need to go into my coefficient of 1 rule and look for two numbers that multiply to be negative 15 and add to be negative 2. Those will be the two numbers at the end here. So let's look at negative 15. Right here are my two numbers, 3 and negative 15. So I'm going to put positive 3 here, negative 5 there. Sorry, 3 and negative 5 are the answers I'm looking for. What goes ahead of this? Well, P plus Q.